Hello Windows Store app developers. Today we're going to talk about process lifetime management, the runtime broker, and suspension manager.
We'll start off here on my Windows 8.1 start page and go into the Cocktail Flow app. Navigate around the app a little bit. Process lifetime management, also referred to as process lifecycle management, was introduced in Windows 8. Here in the Task Manager, we look at the CPU, it's at 0. We'll go back to Cocktail Flow, navigate around a little bit. Go back to the Task Manager, it's at 0.5, it's going to drop down to 0. One more time, let's look at the Cocktail Flow. Navigate around, then quickly come back. 4.3, 4.4, it's going to drop down to 0. So what exactly is going on here? Let's open up Process Explorer, a free tool from Sysinternals. Mark Rusinovich wrote this. Here's Cocktail Flow, and you can see all the threads in the app are suspended. Navigate around. Come back and look. There it is. It's going to drop down to 0, and all threads are going to be suspended. There we go. Suspended. So see this here, the runtime broker? This is a service that's part of PLM that's monitoring any Windows 8 apps, and all those apps that are not in the forefront, it's suspending all threads in that app. Let's go to the properties for this app while we're in here. And there's a bunch of useful information in here. You can go to the .NET Performance tab, and you can view the number of handles, bytes in all heaps, number of pinned objects if you're looking for a memory leak. This is really useful. You can also go to the Image tab here, and you can see where the app is installed. All Windows Store apps are installed under Program Files, Windows Apps. Also, if you have Telrix Just Decompile or another decompiler installed, you can go ahead and reverse engineer and take a look at the code like this. So PLM Debug is part of the Windows SDK, and it's a useful tool for turning off PLM. If you want to be able to take a memory dump, for example, it's not going to have much useful information while all the threads are suspended. So in order to turn off PLM for an app, you need the app ID. Now you can go in and do a PowerShell command like this, get AppX package, sort through that list and find your particular app and find the app ID. I find it much easier just to go in here and use this. I mean, there can be multiple versions of an app installed, like your debugging version versus the one that you're actually testing, for example. So then you just do PLM Debug, enable debug, and then that app ID. There we go. Now that PLM is turned off, Runtime Broker will no longer suspend all threads on that app. That command, PLM Debug Enable Debug, actually sets a registry key. So first we have to kill the app and then reopen it. In Windows 8.1, the default behavior for Alt F4 or dragging from the top to the bottom no longer kills the process. And here we go, you can see now all the threads are not being suspended. Continues to run. And if you wanted to, you could now right click and take a memory dump, and it would have some useful information like create dump. PLM Debug also gives you the ability to send suspend and terminate events. And you can even attach a live debugger like WinDBG. Just have to specify your package name and then the path to your debugger. Let's go in here to Visual Studio 2013, create a new project using the default grid app template. Your app may have one of three states: running, suspended, or not running. Running and suspended I've just shown you. Not running is, well, maybe the app was just deployed, or it crashed, or it's suspended and couldn't be kept in memory. So here we've navigated to an item, and we'll send a suspend and shutdown event. This is not visible by default. You have to enable it using the debug location here to get it to show up on your toolbar. We'll do suspend and shutdown, and then we'll just relaunch the app. And you can see it brings you straight back into the page where you left off. What's going on? So the default template hooks into the suspending event here where it saves state. Then when the app is launched, we look at the previous execution state. If the previous execution state was running or suspended, you don't need to worry about restoring data. Here's where we're actually saving state. So on suspending, we're saving state. Get a deferral, then we save state. And then we check the previous execution on launched. So here we'll send the suspend and shutdown, and here we get the deferral, and we save state. Now if you look at the suspending operation, you'll see that there's a deadline, and that's 5 seconds. You might think you could increase that beyond 5, but you can't. In fact, if you take longer than 5 seconds to save state, maybe calling a web service or doing some XML serialization, the runtime broker will terminate your app. And here we're checking the previous execution state. There's 5 possible values: not running, running, suspended, terminated, or closed by user. And we restore state, and brings us right back to the same page.
Well, that's it for this week. I hope you enjoyed the session. Please join us next time.